Good morning to all. I am Arunima Nag, Assistant Professor, Bengal School of Technology. So today my topic is preformulation study. So as you know that with this topic, it is one of the important topic in industrial pharmacy for the B.Pharm third year students. So over here in this slide, we are going to study about the brief introduction of the preformulation studies, what are its goals, its objectives, next various properties of the drug substance, for example, the physicochemical properties, the physical properties. Next, under the physical properties, we are going to study about the organic properties and the bulk characterizations. So first, we are going to study about the introduction of the pre-formulation studies. So as the name suggests, it consists of the two terms, that is pre and formulation. So pre, as we know, it means before, and formulation means to make anything. So over here, this pre-formulation, it can be defined as the study or the investigation of the physical and the chemical properties of the drug. It can be the API alone, or it can be the combination of the API and the excipients in order to form a drug product or a stable, safe, effective and affordable dosage form. So we can say that this pre-formulation studies, it is one of the most important crucial step in the formulation of any kind of dosage form. Next, we are coming to the goals and objectives of the pre-formulation studies. So, first goal of this pre-formulation study is to make a stable dosage form, safe dosage form and an effective dosage form, and also it should be an affordable one. Next objectives of this pre-formulation study is to determine the physicochemical properties of the new drugs. So now the term this physicochemical properties means the physical properties of the drug and the chemical properties of the drug. Next, to determine the kinetics of the drug, that is how the drug is getting released from the dosage form, and the stability of the drug in case of the API alone or in the formulation of the dosage form, and to establish its compatibility with the common excipients which we are using to make the dosage form. Next, we are coming to the physicochemical properties of the drug substance. Now, this can be again classified into the physical properties and the chemical properties as mentioned above. Now, these are some of the examples of the physicochemical properties of the drug. For example, spectroscopy, solubility, pK, partition coefficient, particle size, melting point, shape, etc. Now, these physical properties of the drug, what do you understand by this? So these physical properties, it can be also classified as the organoleptic properties, the bulk characterization of the drug, the solubility analysis and the stability studies or the stability analysis of the drug. Now this organoleptic properties, it means the properties which we can feel, which we can see or which we can taste. For example, the color, odor, taste and even the texture of the drug. Bulk characterization means that in a bulk what we can measure. For example, the particle size, the surface area, the flow of the particles, density of the particle, compressibility, etc. Next, in case of the solubility analysis, over here we are going to study about the drug solubility in various kind of dosage form, how is the drug it is getting soluble in various kind of solvents, in various kind of medias. Next, in the stability study, we are going to study about the degradation of the drug. Now, this degradation means that the drug, it is not giving you the approximate or the appropriate results, or maybe it can have any kind of impurities and the drug, it is getting degraded. It can be due to the presence of any kind of excipients. That's why we over here also study the drug excipient compatibility. Now, in case of the organoleptic properties, as the name suggests, that means these are the properties which are evaluated after the impression of the organs of sense. For example, which we can see, which we can feel, which we can touch. So, examples are color, odor and taste. So often this color it can be described. These are the some of the parameters or very common colors in case of the APIs or the drugs, that is off-white, cream, yellow, tan, shiny, etc. Now odors in various kind of drugs we can see that they are very pungent in odor, in smell, that is very fruity, aromatic, and some drugs can even be odorless, for example paracetamol. Next is taste. Taste of the drugs can also vary, for example acidic, bitter, bland, sweet, tasteless. These are some of the parameters of the taste. Now this alternative properties, it is very important because over here from this property we can either choose that how we are making the drug formulation. For example, if the taste of the drug it is very bitter, for example in case of antibiotic, so we can see that common antibiotics they are very bitter in taste. So over here we can use any kind of flavoring agent or any kind of sweetening agent in order to improve the taste. So that's why this kind of alternative properties, the study of these properties, it is very important. Next we come for the color. So color it is one of the major alternative properties we have to study in preformulation studies. So if there is any variation in color, it may indicate that there is any kind of degradation of the drugs. Next, in case of various kind of solvents presence, also we can see there is degradation of the drug, and often we can see that various strengths or various batches of the drugs they come in various color in order to identify them. So color over here it is not only it is an indication of degradation, but also it can be used as an identification of the drug product. Next is the odor. Sometimes the odor of the drugs it can be a characteristics of the drug. For example, if we see the characteristic odor of vitamins, it has a very fruity fruity odor of the vitamins. So it can be characterizable that we can see that it is a vitamin. Next, it can be also an indication of the quality of the formulation. For example, if you take an API aspirin, so if there is a degradation of aspirin, we can see that there is characteristic odor of acetic acid. So it can be an indication of the quality of the drugs also. Next we are coming to the next property, that is the taste. So over here taste it plays a major important role in the consumer acceptance. For example, if the drug is very bitter, it may be not accepted well by the children. So in such cases we have to test marks, or we have to make the drug product more palatable for the children. So we can use the flavoring agent, coating agent and excipients in order for the taste masking. So now this API of the drugs, it can come in case of various physical forms. So we can see that there are major three forms of the drugs, that is the solid drugs, liquid drugs and the gaseous drugs. Now this physical form of the drug, it can also be classified as mostly the solid form of the drugs. It can be classified as the crystalline form of the drugs and the amorphous form of the drugs. Now this is the basic difference between the crystalline form and the amorphous form. So as the name suggests, the crystalline form, it has a very crystalline-like structure or a solid-like structure. For example, over here the atoms and molecules, as you can see in the diagram, it is arranged in a definite lattice structure. Whereas the atoms and molecules of the amorphous form, it does not have any kind of definite lattice forms. Next, in case of the crystalline solids, we can also see it has a fixed internal structure. Whereas the amorphous form, it does not have any kind of fixed internal structure. Also in case of the crystalline form, it has a very high melting point and boiling point, whereas the amorphous form, they have a low melting point, boiling point. And since all these properties of the crystallines are superior than the amorphous form, and hence the crystalline form, they are more stable than the amorphous forms. Now these crystalline forms, they are less soluble and the dissolution rate is less, whereas compared to the amorphous form, the solubility it is more and the dissolution rate it is more. For example, there is one drug, that is novopiacine. So over in here, in case of the novopiacine, we can see that the amorphous form of the novopiacine, it is more readily absorbed than the crystalline form. So in this PPT, we can see that how the crystalline habitat influence the physicochemical properties of the drug. For example, you are making any kind of dosage form. So how the crystalline property it is impacting them. For example, you are making any kind of suspension. So over here we have to see that the crystalline form may impact the suspension stability and the syringeability of many kind of dosage forms. For example, penicillin G, it is more stable in case of the crystalline form than the amorphous form. Also, if we see about the flowability, we are making a suspension, we are making a parenteral. So over here, the flowability it is important in case of liquid dosage forms. So we can see that the plate crystals, they have more flowability than the needle shape. Next, if you are making any kind of tablets, so this crystalline habitat or the crystalline property, they also impact the tableting properties. For example, they may alter this tableting property due to the crystal packing during the compression. Next, dissolution. So the crystal structure, they also affect the surface area for the contact angle with the solvents, and it will impact the dissolution rate or the release of the drug from the dosage form. Next will come for the polymorphism. So polymorphism, as we know that this is the ability of the compound or ability of a substance to obtain or to be present as a crystal in more than one distinct chemical identical crystalline species with different internal lattice or the crystal packing arrangement. So this polymorphism, in simple word, it means that the crystals over here will have the same chemical structure but it will have different physical forms. So over here this is an example of the sulfur molecule. As you can see that this sulfur molecule, it has total 8 molecules, S8. So this S8 it is in crown structure, but if we increase the temperature about 369 Kelvin temperature, so it will form into a monocyclic sulfur, that is a needle shape. It also has 8 molecules, but over here it is a needle shape. And if we lower the temperature below 369, then it will change into a rhombic structure or a octahedral structure. So over here we can see that the physical form of the drug, it is changing, whereas the chemical nature, it is the same. So the properties of these polymorphs. So the properties of polymorphs, they show the same properties in liquid or gaseous state. They behave different in the solid state. So polymorphs, they differ from each other with respect to the physical properties like the melting and sublimation temperature, vapor pressure, solubility, dissolution rate, stability, optical properties, crystal habitat and hygroscopicity. So next important properties in the physical properties of the dosage form is the particle size and the shape. So this particle size and shape, they not only affect the physical properties of the drug, but in some cases also they impact the biopharmaceutical behavior. That is how the drug it is getting released, that is how what is the impact of the drug in our body. So the size, shape and the surface morphology of the drug, it affects. So major these 3 parameters it will get impacted. First is the flow property, next one dissolution, and the third one is the chemical reactivity of the drugs. So what is the significance of this particle size? First, the particle size, it influences variety of important factors, that is the drug dissolution rate. So now how this dissolution rate will be impacted? As you can know or you can see that if the particle size is very small, it will give you an optimum or a quicker release from the dosage form, and hence the dissolution rate of such particle will be improved. Next, content uniformity, texture, stability, flow characteristics, sedimentation rates, penetrability and suspendibility. So this particle size, it can also be classified or characterized into using some various terms. For example, very coarse, coarse, moderately coarse, fine and very fine. So this particle size, they significantly influence the oral absorption profile of certain drugs. So these are some of the methods of determining the particle size. First one is the sieving. If the particle size range is from 5 micron to 150 micron, you can use the sieving method. Next one is microscopy. If the particle size is 0.2 micron to 100 micron. Next one is sedimentation rate method, when the particle size is 1 micron to 200 micron. Next one is the light energy diffraction method, when the particle size is 0.5 micron to 500 micron. And last one is the laser holography, when your particle has the size of 1.4 micron to 100 micron. So this is the explanation of the sieving method. As you can see in this animation, this is the sieving machine. So over here, various kind of sieves, they are being stacked together, and then we give a proper time and we set a time, and then the machine, it works on the properties of the vibration method. So over here we are in the first sieve, we put our material, and then due to the vibration it causes the shaking of the sheaves, which causes the separation of the particles in form of various particle size. So from here we can separate out the particles based on the size. Next one is the sedimentation rate method. So over here in this animation, you can see that over here 3 colors are mentioned over here, and these 3 colors, they indicate the 3 different particle sizes of the product. So as the color over here, we can see first, if the particle size is very high or it is larger, we can see that this particle tends to sediment down faster rather than the particle size. Over here in yellow, it is showing it is having the smaller particle size. This will tend to be suspended in the suspension. So from here we can say one example is, whenever you are making a suspension, if the particle size is very high, it may cause the caking of the suspension. Whereas if the particle size is very low, it may cause the formation of charged particles, and then it may also cause the propagation of the particles or various kind of suspension problems. Next one is the laser holography. So this method is also used for the evaluation of the particle size. So from here we can see that this is our cuvette, which is consisting of the solution having a mixture of various particle size ranges. So whenever you are introducing laser light through this solution, we can see that there is a separation of the particles, and this is based on the principle of the Brownian motion. So over here, when the laser it is getting passed, there it causes the excitation of the molecules, and we can see if we plot the graph between the intensity and time, so this graph we can see that there are various noises formed, whereas in this graph of the larger particles we can see there is the noises are less. That means in case of the smaller particles, due to the larger or faster Brownian motion, these particles tend to collide faster, and which causes these noises. Whereas in case of larger particles, there is less collisions, and we can see that this over here, the noises, it is very less. So as said before, that particle size determination, it can be done through microscopy, sedimentation rate method, filter counter method, and the surface area determination method by the nitrogen absorption method. Now, when this particle size reduction, it is not required in the dosage form. We have seen that if we reduce the particle size, drug will release faster, the solubility will be high, the dissolution rate will be high. But there are some cases where we do not use the reduction of the particle size. For example, when the drug is unstable in nature. So if you reduce the particle size, it will cause charge effect on the particles, which will cause it to be more unstable in the nature. Next, If the particles or if a drug it is getting degraded in the solution form, in such cases we do not use the particle size reduction method. Next, if we want to produce undesirable effect, if your drug is giving already an undesirable effect. Next, when there is a sustained effect is desired, whenever a sustained effect is desired, if you release the size, then the drug will get released faster or immediate release. So in such cases, we will be not getting our optimum result. And lastly, the application of the particle size in preformulation studies. So, in cases of suspension, we can see that the particle size it is one of the most important parameter which determines the stability and the quality of formulation. So, if there is a too much reduction of the particle size, it may cause the generation of charged particles, and hence it will make the formulation unstable. So, the larger particles, if the particle size it is of higher, then you can see that it may tend to sediment down faster and it will lead to caking in case of suspensions. So, due to the non-uniform particle size distribution, there is a significant risk associated with the content uniformity of the juice form and in case of the potent formulations. So, this was some of the examples of the physical forms of the preformulation studies. I hope you have enjoyed this. So with this I conclude my topic for today. Thank you.